Man, I'm tired of absolute values. I have an idea. Let's learn a new function. Here we go. Welcome to 3.5 where we're going to start graphing quadratics. So let's talk about this thing called the quadratic function. So you've probably seen it before. This is your just general ax squared plus bx plus c. This is kind of the most common formula that we're going to be working with. It's called a quadratic formula. Generally, if you see an x squared and that's your highest degree or your highest exponent, you're dealing with a quadratic formula. So a couple things to take note. So first of all, when we graph it, the general shape is a U shape. So this little line right here is our axis of symmetry, which hopefully you remember from geometry. If it's symmetrical, it's the same thing on both sides. So yes, these do have an axis of symmetry. So another vocabulary word you need to know, this part right here. So this dot where both things come out, that's called a vertex. So we've got a vertex and an axis of symmetry. That vertex is super important. We will talk about that a lot. The name of this shape is called a parabola. Again, still just kind of looks like a U. And what else we got here? So when it faces up, we've got the vertex right here. That's also going to be a minimum, the lowest possible value for y. So just like the absolute values, the domain for this is going to be all real numbers, and the range is always going to start at the vertex and go up for a parabola facing up. So that's this equation right there. Notice there's no numbers here because it's just kind of a general familiarization with what the graph looks like. So notice when we put this negative sign here, so just like absolute values, it flips it over or it mirrors it around the x-axis. So here, with this negative sign, we now have a parabola facing down. So we still have the vertex, we still have an axis of symmetry. Those are all important things, but now the vertex, instead of being a minimum, it is now called a maximum. So this is kind of important, in business because we want to maximize our profits or minimize our costs and things like that. So that's kind of why we talk about it, and it's kind of important to know. So how do we graph one of these things? So since all of these parabolas are in standard form, not like vertex form yet, we'll go over that later. But remember, our standard form is right up here. But since they're in standard form, in order to graph it, the first thing we need to know is that axis of symmetry. That will give us our vertex, and then from there, we'll just throw some points at it and make our graph. So the way we find our axis of symmetry is this guy right here. So write this down. We are going to use this problem this formula on every single problem that we do. So x equals negative b over 2a. And remember, all of these things are in standard form. So our a is the number that is attached to the x squared, our b is the number attached to the x, and our c is the number by itself. So x equals negative b over 2a. That is the axis of symmetry. So that's what that says right there. And the turning point is called the vertex. We talked about minimum, maximum, and we already labeled the parts above. All right, let's try some problems. Okay, so you'll see that I just already wrote x equals negative 2b over, x equals negative b over 2a on all of my problems because like I said, we're going to use it every single time. So if we look at one here, we've got 4x squared. So you'll notice that I already wrote it down, but this is the same as saying 4x squared plus 0x plus 0. That's where this 0 and that 0 come into play. So just because you don't see the right number doesn't mean that it's not there. It's just probably a 0. So in this case, a is 4, b is 0, c is 0. We're going to plug it into our vertex formula. So that means that we're going to have x equals negative b, which is 0, over 2 times a, which is 0. So our axis of symmetry is x equals 0. And our vertex, the x value is going to be 0, sorry. And then our y values, we're just going to plug 0 back into the equation. When we do that, we plug it into this equation right there. X equals 0. 4 times 0 is still 0. So our full vertex is going to be at 0, 0. And that is going to be a no, just kidding. That is going to be a minimum because it's our normal parabola because there's no negative sign right there. So that means that our vertex is going to be down here. So that is going to be our minimum. All right, number 2, again, we got to figure out which one is A, B, and C. So in this case, our A is going to be equal to -1. I got that from right there. That's the number that's attached to the x squared. The B equals this number right here, the number attached to the x. And then our C is non-existent. It's not there, but we can pretend like there's a +0 right there. So our C is going to be equal to 0. So then from there, we can plug that in. So for my vertex, x equals -6 over 2 times A, which is -1. My negatives cancel out, and then 6 divided by 2 is 3. So we're just going to have a +3. And then from there, looking at my equation, that negative sign means that it is a graph that kind of looks like this. That means that we're going to have a maximum, and my axis of symmetry is x equals 3. So then my vertex, my x value is going to be 3, and we're going to plug 3 back into this equation. So when we do that, we've got -3. Notice how I use my parentheses there. So that negative sign is on the outside of x, and that square does not hit that negative sign. +6 times 3 plus 0. So that is -9 plus 6 times 3 is 18. Which all that is going to equal a +9. So my vertex is 3, 9. Remember, the vertex is an actual point, so it should be labeled like that as a point. All right, a little bit more practice here. The important concept here is being able to figure out which one is your A, your B, and your C. So make sure that you can do that. The rest of it, you just plug this in there, and then we just kind of, do some math, I guess. Anyway, so in this case, our A is going to be -2. Our B is non-existent. There is no x value, so it's an implied 0. So that's why we got B equals 0. And then our C is going to be the number by itself, so we got C equals 7. So we're going to find our vertex, and our x equals -b over 2 times -2, so that still equals 0. And let's see here. Our graph is going to look like this, sort of, and I know that it's facing down because we have a negative sign right here. And from there, our vertex is going to be up here. That means that I know that my vertex is going to be a maximum. My axis of symmetry is going to be the line, the vertical line of x equals 0. And then my vertex, I'm going to plug this 0 back into the equation. So x equals 0 right there. This whole thing cancels out because it's times by 0. We have 7 left over. So my vertex is at x equals 0, y equals 7. And number 4. So again, we need to figure out what our A and our B is. So our A equals the number that's attached to here. There is no number, but there is an x squared. So that is an implied 1. Our B is going to be -8. And honestly, at this point, we know that we're not going to use our C for this problem. So here we go. We're going to add our a and b into our formula. So that's negative b over 2a. Again, notice my parentheses. This negative sign is on the outside of this parenthesis, so it is going to end up canceling out, but those parentheses really help make sure that you keep your negative sign straight. So that's going to be 8 over 2, which is equal to 4. And looking at this number, the fact that it is positive and not negative, we know that we're going to have a minimum. Our graph is going to kind of look like this. And our axis of symmetry is going to be at x equals 4, which means our vertex is going to be at 4, comma. We are then going to plug 4 back into this equation. So we've got 4 squared minus 8, 4 plus 9. And I'm honestly just going to plug that into my calculator. 4 squared minus 8 times 4 plus 9. So then we get negative 7. Negative 7. Okay, let's put it all together. So I skipped straight down to number 7. I'm not going to do all of these examples, but they are there if you want some extra practice. So number 7, notice how I already have my x equals negative b over 2a written out. That's the equation we're going to use over and over again. So anyway, we're going to find our vertex. So we are trying to graph, and the first step we need is the vertex and axis of symmetry. So that's what we're doing. So then we're going to plug our negative b over 2 times a. Notice my parentheses again. So we're going to have positive 8 over 4, which equals 2. So now that you know our vertex, just like we did with the absolute values, we're going to put that vertex right there. Now here with parabolas, it's a little bit more important to make sure you have at least 2 points above and below the vertex, because it helps us figure out how to curve it. Whereas the absolute values, we knew it was a straight line, so you could probably get away with 1. Parabolas, it's really important to actually have 2 points so you know exactly how curvy to make the curve. It's a technical term, by the way. Anyway, so we're going to plug this in to this guy right there. So if I do all of that, we're going to have 2 squared, which is 4, times 2, which is 8, minus 8 times 2 is 16, plus 6. So we're going to do 8 minus 16 plus 6. So our vertex is going to be at negative 2, negative 2. So then you can use your calculator for the rest of this. And on the next problem, I will actually show you how to do this on the calculator very quick and easy. But for now, you're just going to plug, you're going to pick your x values. So 2, 1, 0, and 3, 4, just like we did with the absolute values. And then you're going to plug those numbers into here, and you're going to solve every single one of them. So our answers are going to be, we plug 1 in, we're going to get 0 and 6. Then we're going to get 3, 0, and 4, 6. So then from there, now we can graph. So we've got our vertex at x equals 2, negative 2. So I'm going to put a dot there, and then 1, 2, 3, 0. And again, since it is an axis of symmetry, I already know where the other one is. And then 4, 6. 1, 2, 3, 4, 5, 6. So you'll notice that it is more important to have those 2 extra dots just to see how to make that parabola. So then from there, our domain and range, everybody's favorite. So our domain is all possible x values. So where can I draw a vertical line and it will cross? So believe it or not, over here, it will cross, but it's all the way up there somewhere in Never Never Land. But parabolas in general are always going to have all real numbers. Again, if you're a memorizing person, you can probably just memorize, hey, if I have a parabola, the domain's going to be all real numbers. The range is going to be a little bit more interesting. So the range, it will start right there, and it goes up forever. So then we can write y is greater than or equal to whatever that number was, -1, 2, -2. And then in interval notation, it would be -2 to infinity. Whichever style of writing makes you happier. Okay, I'm at number 9, and man, that just looks like a lot of math, right? So we've got some fractions, and I mentioned we have this great and wonderful device that will do all of this math for us. Yay, computers. So we do still need to find our vertex because we need to know where to start and where to look, where to find our points. So I am going to do the -b over 2a. So we've got -b, my b is -1, all over 2a, which I know it's a fraction, but, well, at least it cancels out, so that's fine. And then, let's see here, so -1/2 times 2 is just -1. So then our vertex is going to be, looks like we got 1 over -1, which is just -1. Okay, so we're going to put -1 right there. Now, if I was going to do this all by hand, I would recommend doing like even numbers that would make math a little bit easier. So I would do like 2 and 4, and then -2, and then -4. But we're going to use the calculator so we can do as many points as we want. So we're going to do -2, -3, -4, 0, 1, and 2. So the things that we're going to need to know our formula. We're going to enter that into a calculator, and I'm going to show you how to get all of these points really quick. All right, here I am on a calculator. It should look similar to yours. Just so you guys know, if you look right down there, that's where my key history is. So that's a good place to look if you kind of forgot which button I pushed, things like that. But anyway, we're still in number 9, and our equation is -1/2 x squared minus x. We want to be able to have a chart and enter a whole bunch of points and get a whole bunch of points back. So what we're going to do is we're going to go to y equals first, and we're going to enter in our equation. So first of all, remember, if you're using the negative sign that is attached to a number, it's this button. If you are using the subtraction function, it's this button. If you get those confused, you'll get like a syntax error or something like that. So we've got -1/2. We're going to use this button right here for our x. And that was x squared. So we've got -1/2 x squared minus x. Okay, so we've got our equation entered in. So we can look at the graph. We can already kind of see it, except my face is in the way. But, you know, our math teacher is making us make a chart. So we want to figure that out. So instead of graph, we want to go up here to table. In order to get to table, we need to push second and then this button, which will take us to a table. So right now, we've got all these values because we have it set up in our settings to automatically pick up all these numbers. But I want to be able to enter the values in myself because if you remember, the values that we want were like 0, -1, -2, -3, -4, things like that. So let's see here. We're going to go to table set right here. And so hopefully if you took any science or anything like that, we've got our independent or a dependent. So the dependent would be the return values, or in this case, the y values. The independent is the x values. So we want it to say ask. So we're going to scroll down and turn that over to ask. So we have ask highlighted, push enter. So now when we go back up to our table, second graph, there's no values because we get to enter them in. So just like we have on our sheet of paper, I'm gonna go -4, and it automatically pops out our value. So here, we can very quickly fill out our table, making our wonderful and amazing math teacher happy and showing that we have an understanding of how the using the point method or making a chart works, but without having to do a super huge amount of math. And even here, you can kind of see a pattern as we go down. Let's see here. What was our x was, I'm sorry, our vertex was at -1. So then here would be our max, and then it goes down from there, just like what we saw on our graph. So you can just copy these down onto the sheet, and we're good to go. So we've got the points, the numbers in our table, and we're going to graph them. So -1, and then 1/2 is kind of like there. -2, 0. -3. -1.5. And then -4. 1, 2, 3, 4. 1, 2, 3, 4. And here we have our graph. And as I mentioned earlier, our domain for all of our parabolas is all real numbers. And our range, it's going to start there and go down. So that's going to be y is less than or equal to, what is that, 1/2. If you put 0.5 there, that's fine too. So graphing quadratic inequalities, hopefully you're noticing a pattern. It's the exact same way, except now we have to shade. We got solid lines, dotted lines, which I'll probably mess up, but it's the same concept. We're just applying it now to quadratics. So I'm looking at number 1. Step 1, we need to graph. So we need to find the vertex. Got my x equals equation written up there already. So then -b, so that's going to equal -2 over 2a. In this case, a is 1, so that means that my vertex is at -1. So I'm going to put that right there. So then I'm going to choose -2, -3, -4, -1, 0, 1, 2. I'm going to use my calculator, make a table so that I can get the values down real quick. We enter x squared plus 2x minus 2 in the y equals function, and then go to second graph. That'll take us to the table, enter in my values, and it's going to tell me 6, 1, -2, -3, -2, 1, and 6. Okay, so now we need to graph those points. I always like to start with my vertex because it makes sense. There's a line of symmetry there, and that is at -1, 3, -3, -1, 1, 2, 3. So then we got 0, -2. We got 1, 1. Where am I at? 2, 6. 1, 2, 3, 4, 5, 6. So let's see here. Since we're doing inequalities, I guess I got to do a dotted line. That's gross. I hate doing dotted lines, but it's fine. So there's my dotted line. So then we got a shade. So y is greater than or bigger than the thing that we made. So again, I can just shade on the inside there. And once again, if that doesn't make sense to you, you can always plug in 0, 0. If I were to plug in 0, 0, I would have 0 is greater than 0 plus 0 minus 2, which means that would say 0 is greater than negative 2. Is that a true statement? That is a true statement because I would rather have $0 instead of owing you $2. That would be like negative 2. So 0 is bigger, so that means I would shade toward 0, 0, which is the origin. And again, either one of those methods work. I would encourage you to figure out the one that works best for your brain and really focus on being proficient at that. But other than that, that's the lesson for today. We're just graphing parabolas. So I'll see you in class.